Relief batteries, recycling lithium-ion electric vehicle batteries.
Current electric vehicles were a viable solution 10 years ago. However, not today and definitely not tomorrow. In today's world, there is a major lack of ethically produced/mined materials, and to add fuel to that, there has been an exponential increase in cost for these materials.
So what can we do to abate this? 1. We can look for new types of drivetrains. 2. We can stop the production of electric vehicles and reuse the current ones till their batteries die. 3. We can start recycling end-of-life electric vehicle batteries for raw materials.
Our idea is focused on the third solution. Why? Materials used in electric vehicles can be used to manufacture more electric vehicles in addition to millions of other items.
So what makes an electric vehicle's battery? Plastic coverings, metal sheets, cooling mechanisms, and the acid or cells. We have figured out a way to recycle these old cells to extract the previously mentioned materials, such as cobalt, nickel, and lithium.
We have found a way to recycle these old cells to extract the previously mentioned materials. But how do we do this? We cannot discuss the exact process right now because we are filing a patent. Although we can say that the process is different for each material, but it could be combined to form a singular chain reaction.
The goal of our idea is to find the solution to a problem yet to be faced when the resources have depleted, while we need more electricity and less waste around. Thank you.
Increased temperatures around the world are causing the oceans to become more acidic. When the oceans become more acidic, this leads to coral reef death. Coral reef death can have coral reefs can actually be the solution for many of the problems that we're facing around the world. One of them being the rising sea levels, severity of storms, and damaging coastal areas. All of these have a big economic burden. And as an example here, you can see around the world, there's an estimated GDP loss for no adaptation on coastal area damages. And then to the right, full adaptation for coastal area damages. So one of the actions that we can implement is increase coral reefs around the world. That's the action we propose. And weather damage. So there's a lot of economic burden related to weather-related disasters, and it's only increasing. So it just highlights more the need for the solution. So what's our solution? Our solution is creating an environment throughout these coral reefs that prevents them from dying. The acidity of the ocean is what makes this coral reef die. So what we're gonna do is we're gonna use geobacter, which is a bacteria that produces excess electrons, and so it would release those electrons into the environment, and it would mix with the hydrogen ions. So with the acidity, that would create water. So around the corals, it would decrease the acidity of the water and create an optimal environment for the growth. They will then grow and dissipate the wave energy, dissipate the oceans, decrease the erosion, and help all of us live in a better world and lessen our economic burdens. Thank you.
Physical therapists are currently understaffed and forced to work 8-hour days tirelessly repeating the same exercise movements on patients, which is physically exhausting for them. Additionally, by having to repeat these monotonous movements with patients for long periods of time, they're only able to see half the amount of patients an ER doctor gets to see at only 2 an hour. As a result, it can cost clients up to $150 out of pocket for each session because the physical therapist has to spend so much one-on-one time with them instead of being able to see multiple patients at the same time. To solve these problems in collaboration with several meetings and support from engineering and kinesiology professors, I'd like to introduce you to Omnidirectional Therapeutic. Omnidirectional Therapeutic is a machine that physical therapist firms would buy and put in their offices like any other exercise machine, such as an elliptical. Below are CAD prototypes, but the actual machine would look a lot more visually appealing for the customer to trust using it. The machine will work by first having the physical therapist diagnose the client and input their body dimensions and exercise treatment plan into the machine's monitor dashboard. Then the client would step one of their feet into each pedal shown below in the bottom right picture. Their torso would be stationary and strapped to the machine as well. Then the white cable shown in the bottom left picture would move via the motorized spools at the end of the diagram to move the foot brace, which would move the person's ankle, knee, and hip according to the physical therapist treatment plan for them. The machine can move the person's leg to perform simple, repetitive leg bending motions to advanced movements like walking in accordance to the person's body type and required machine support. This will allow physical therapists to see multiple clients at once by being able to diagnose one of their clients while having the other on this machine that automates the rehabilitation exercises for them. Once this technology is researched more, the machine can be used by senior citizens to help them continue walking safely. Then, eventually, it can also have different cables attached to the person's torso and arms to be replaced into exercise equipment like ellipticals, be a simulation for sports like rock climbing, simulate gravity on different planets like Mars for astronauts, and even be for recreational home use for things like VR. Thank you, judges.
Welcome to Space Janitor. In humanity's endeavor to explore the solar system, we left behind a trail of debris in the wake of our scientific achievements. There are currently about 32,000 space debris objects orbiting Earth, totaling about 10,000 tons. Of those mass, about 7,000 tons are payloads, and 3,600 of them are rocket bodies. The most expensive and costly equipments were floating in space, including solar panels, antennas, batteries, and structural parts. Just one component broken can render the whole system inoperable. Some of them waited silently in graveyard orbits to be claimed. And our goal is to reuse and recycle space debris in the most economical way. Hence, we propose the space junk aggregation, neutralization, in situ transformation, and orbital recycling solutions, or Space Janitor. The idea is to collect space debris from various orbits with an orbital cleaning drone, retrieve them to a recycling platform to dismantle space debris, reuse the repairable parts, process irreparable parts into raw material for storage, leaving no waste unused. And by recycling and reusing the processed materials, we can use them for spacecraft servicing, maintenance, refueling, and on-orbit manufacturing. Our solution is to engineer a modular station on low Earth orbit, launch it to operational orbit, clean the orbit, and gradually evolve the station with additional modules for extended functions, and one day turn the space debris recycling platform to an on-orbit industrial platform. The Space Janitor will profit from the sale of recycled materials, the commission for space debris removal, on-orbit spacecraft servicing, spacecraft refueling, on-stations manufacturing, and rental of modules. Space Janitor, we are clearing up for a brighter future.